Hey, 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 what's up, everybody? Welcome to day 3 geometric sequences. Out. So these types of sequences are found by multiplying to get the next term. So let's do that. What do we got to multiply by to get the first and second and third terms here? I think we're multiplying times 5. Basically, I'm just going to write this times 5. And so 250 times 5 gives me 1,250. What are we doing here in the second term? It looks like we're, oh, by the way, if you hear any piano or organ sound, that's just my son and daughter. They are playing the piano or the keyboard in the background. It looks like we're getting smaller and smaller. To be specific, it looks like we're dividing by 2. Now, I'm going to point this out throughout this entire lesson. We're never going to say divide. Dividing by 2 is the same as multiplying by 1/2. Cutting it in half is the same as dividing by 2. So, cutting in half, you get 8. Here it looks like we're multiplying by 3. And if you multiply by 3, you get negative 405. And in the last one, ooh, looks like the denominator's doubling each time, so it looks like we're multiplying by 1/2 again. So the top stays 1, and the bottom gets twice as big, so 1/16. Done. All right, these are all examples of geometric sequences. Geometric sequences are sequences where not a common difference, but a common ratio, R, is multiplied to get each term. And we're going to write the formula right here. I'm not going to build it up like I did before, but I just want you to recall for arithmetic sequences, the formula was a sub n, which is the nth term of the sequence, any term, is a sub 1, which is the first term, plus d, which was the common difference, times n minus 1. So the formula for a geometric sequence is very similar. It's a sub n equals a sub 1. But instead of adding, we are going to be multiplying this time, times r. And r is the common ratio, raised to the n minus 1 power. Because think about this. Instead, how do you show repeated multiplication? If I wanted to do 2 times 2 times 2, I would say 2 to the third power. So you raise it to the n minus 1 power. All right, so a sub n still represents the nth term. A sub 1 represents the first term. And r represents the common ratio. Not common ratio, common ratio. There we go. And n represents the term number, whichever term you want to deal with. All right. So big point here. To find r, even though we're multiplying to get each term, to actually find r at any given point in time, you divide any term by its previous term. So look at the first set of directions that I kind of wrote over a little bit. Determine if the sequence is geometric. If it is, find the common ratio. So how do you know if something's geometric or not? Find r and see if the ratio is the same between each term. So you have to do it multiple times. So I'm going to do the second term, 6 divided by the first term, negative 1, and I'll get negative 6. I need to try it at least more than once to determine if I get the same ratio each time. Let's try the third term divided by the second term. Do I get negative 6 again? It is. Yes, it is geometric. Let's try number 3 here, r. If I take the second term divided by the first term, 16 divided by 4, I get 4. Great. If I take the third term, 36, divided by the second term, 16, that reduces to 9/4, which is what, 2.25? And these terms are definitely not equal. So no, this is not a geometric sequence right here. If you're not multiplying by the same term each time, then it is not geometric. That's it. I'm going to power through these examples, so please stop, rewind, and watch again. These are the types of examples you're going to have in your homework. All right, given the formula for the geometric sequence, find the first 3 terms. Okay, so I'm just going to get right to it. So the first 3 terms, just like arithmetic, is a sub 1 a sub 2, and a sub 3. All right. So if you hear Ludwig van Griffin back there, he's singing. All right, so this is going to be 3 to the 1 minus 1 power, which is 3 to the 0 power. This is 3 to the 2 minus 1 power, which is 3 first. And this is 3 to the 3 minus 1 power, which is 3 squared. All right, so recall, anything to the 0 power is 1. And 3 to the first is 3. 3 squared is 9. Done. Do the same thing here. A to a sub 1, a sub 2, a sub 3. So this is going to be 5 halves to the 4 to the 1 minus 1 power. So it's 5 halves times 4 to the 0 power. What's anything to the 0 power? 1. So it's like 5 halves times 1, which is just 5 halves. First term, done. This is going to be 5 halves to the 4 to the 2 minus 1 power. So it's 5 halves times 4 to the first power. Or I'm going to say 4 over 1, and then 5 halves times 4 over 1. 2 goes into 4 twice, and 5 times 2 is 10. Last but not least, let me just do it over here. So it's going to be 5 halves times 4 to the 3 minus 1 power. So that's going to be 5 halves times 4 squared. By the way, if you ever want to use the calculator feature that I sent to you, I sent you the link for a free license. Here it is. This is what it looks like. You could do this exactly like this. 5 halves, parenthesis, times 4 to the power of 2, 4 squared, and hit to the right arrow to get out of the exponent and close the parenthesis, just like the calculators in class. Look at how cool that is. 5 halves times 4 squared is 40. You can get this for free on your computer. I did this on my laptop the day I sent it to you. Just click on the link to the website. They'll give you a license and a free license for 6 months and use it. It's a graphing calculator on your computer. So that was 40. Done. Okay, let's move right along. Oh my goodness. Did I mess up a little bit? Yes, I did. It was negative 5 halves the whole time. So negative 5 halves, that makes this negative 5 halves. This was negative 5 halves, which makes this negative 10. This was negative 5 halves, which makes this negative 40. I hope you all can forgive me one day. My goodness, Mr. Cody. All right, so here we go. Write the formula for the geometric sequence. Given this information, they're giving you the first term and R. They're giving you the whole darn thing. So it's just, this is piece of cake problem. A sub n equals a sub 1 times R. Always put R in parentheses. Raised to the n minus 1 power. That's literally it. It just says, write the formula. You're done. A sub n equals the first term 2 times R, which is 4, raised to the n minus 1. You're done with 13. Do not overthink the problems. Just do what they ask. All right, we move on to the next set of problems. Notice how I am powering through these right here. Write the rule for the geometric sequence, then find the first 3 terms. So it says that a sub 4 is, oh boy, oh boy, oh boy. Now they're giving you a toughie here, aren't they? They're giving you a real toughie. All right, so what could you do with this then? I know that the first term is 25. I'm sorry, I know that the fourth term is 25. And I know that the formula is a sub n equals a sub 1 times R raised to the n minus 1. So since I know that the fourth term is 25, let me write that. The fourth term is 25, and that's the mystery first term times negative 5 raised to the 4 minus 1 power, which would be to the third power. Remember, to get to the fourth term, you have to raise it to the 4 minus 1 or the third power. All right, so 25 equals, let's see here. What is negative 5 to the third? It's negative 125 times a sub 1. Let's divide by negative 125. And I get a sub 1 equals 25 over 125, which I believe is negative 1/5. Whew. That was a tough one right there. Gee, so wait, we're not even done yet. It says then find the first 3 terms. Don't overthink this. The first term is negative 1/5. The second term is negative 1/5 times negative 5 times negative 5. I'm going to do negative 5 over 1. 5 cancels here, negatives cancel here, and you're just left with 1. And then the third term, I guess, would be 1 times negative 5. And what's 1 times negative 5? Negative 5. All right. Boy, oh boy. Did we miss anything? Oh, yeah, I guess we did. We forgot to write the formula. Okay. So it says write the rule. So it would be a sub n equals negative 1/5, which is the first term, times negative 5 to the n minus 1 power. There's the rule. So I found the rule, and I wrote the first 3 terms. Done. Given 2 terms in a geometric sequence, find the 8th term. All right. Be absolutely honest with you. You can tackle these algebraically, or you can tackle them kind of logically. So I'm checking this out right here. The first thing I want to do is find R, the common ratio. Let me scroll back up. Let me scroll back up in our notes. To find R, you could divide any term by the previous term. Let's scroll back down to this problem. I know the 5th term is negative 6. I know the 4th term is 12. So R could be the 5th term divided by the 4th term. That's negative 6 divided by negative 12, and that's positive 1/2. Now, now I know to get each successive term, just cut it in half. So I know that 1, 2, 3. I'm trying to find the 8th term. I know that the 4th term is negative 12. I know that the 5th term is negative 6, and I'm trying to get 6, 7, 8th term. Notice there's not much algebra going on here, but who cares? We're working on it. Just now I know I'm just cutting in half each time. Multiply by half, so I get cut this in half, get negative 3. Cut this in half, and get what? Negative 3/2. Cut it in half again, and get what? Negative 3/4. And that's it. That's all she wrote. All I'm doing is cutting each term in half. Okay. And that's the deal there. All right. 18 might seem a little tougher here. So 1, 2, 3, 4, 5, 6, 7, 8. Here's the 8th term, the mystery one that I'm looking for. All right. I know the 2nd term is negative 6. I know 3, 4. I know the 5th term here is 48. So it looks like they're getting bigger. Let's tinker here. 6 times 2 is 12. 12 times 2 is 24. And 24 times 2. So it looks like times 2. But be careful here. 6 is negative. So let's see. So we could do 12. We could do 24 and 48. But how do we get the terms to be negative and positive? Ooh, what if R was negative 2? What if you're multiplying by negative 2? Negative 6 times negative 2 is positive 12. Positive 12 times negative 2 is negative 24. Negative 24 times negative 2 is positive 48. I think we've stumbled into the perimeter of wisdom here. 48 times negative 2? Negative 96. Negative 96 times negative 2? Oh my goodness. I'm going to do it on my side calculator. Negative 96 times negative 2 is positive 192. And positive 192 times negative 2 is negative 384. So who says you need algebra all the time? You could use a pattern. That's what sequences are. They are patterns to figure out your answers. Hope you're watching that. Rewind it and replay it if you have any issues with that. Okay, 1920, same deal. 21 through 24. Determine if the sequence is arithmetic or geometric. Remember, arithmetic is adding, geometric is multiplying. So I'm thinking here, how to 2 to 14 to 98. Definitely not arithmetic. I mean, from 2 to 14, you have to add, what, 12? You're not adding 12 to get to 98. 2 times 7 is 14. Check with your calculator. Does 14 times 7 give you 98? It does. So R equals 7, and it's geometric. You could just write G if you want to. You could write A or G. let's see here. Oh, 12 minus 4 is 8. 8 minus 4 is 4. Yeah, so this is arithmetic, but D is -4. Remember, if it's arithmetic, make sure you write D. If it's geometric, make sure you write R. 2, 4, 6, 8. Who do we appreciate? Arithmetic sequences, that's who. And D equals 2. I hope you figured that one out. Add 2. 5, 10, 20, 40. I think we realized this one, geometric. From 5 to 10, from 10 to 20, you're multiplying by 2, so R equals 2. All right, y'all. That's it for those problems. Now we slide on to the end problems here. My goodness, we're getting to the very end. I hope, my goodness, this is a long one. Find the next 3 terms of the sequence. Write the rule. Okay, how do you find R? Find R, you can take any term divided by the previous term. Okay. And when in doubt, if you need to, go to your calculator. Okay, 72 divided by 216. And you're going to get a decimal right there. Now, point to repeating, that's kind of easy. But if you're not sure, remember, how can you change a decimal to a fraction on your calculator? Math, enter, enter. And of course, it's 1/3. So R equals 1/3. Let's get to our lesson here. So this reduces to 1/3. Calculator's cool. Just get the product license and get a free thing right here. Then write the rule. All right, fine. So write the rule. It's A sub n equals 216 times 1/3 to the n minus 1 power. We wrote the rule. And then the next 3 terms. So 8 times 1/3. Let's just see here. I'm just going to go dash, dash, dash. That's going to be 8 divided by 3. Then 8 divided by 9. Then 8 divided by 27. What did I do? I just multiplied by 3 in the denominator. Okay. And last but not least, I'll do one of these problems and call it a day because it's been a long lesson. Write the rule for each geometric sequence described and find the specific term. What's the 10th term when the first term is -6 and the common ratio is 2? So first term is -6. The common ratio is 2. They're just giving this to us. My goodness. So A sub n equals the first term times R raised to the n minus 1 power. And they want to find the 10th. They want us to find the 10th term. So they want us to find A sub 10. That's going to be -6 times 2 to the 10 minus 1 power, which would be -6 times 2 to the 9th power. Let's consult our calculator. So -6. Remember, you're hitting this button down here. -6 parenthesis 2. And you can close your parenthesis if you want to the 9th power. Hit enter. -3072. How cool is having that calculator right there on your computer screen? What was it again? -3072. All right. Good job, everybody. Long lesson. Check your homework and then try looking at this video before you do your homework problems. Good luck, everybody. Ask questions if you have them. Bye.